Okay, so today it's going to be about the coordinate plane. Now first there's two types of planes. First the Cartesian plane, which you're probably used to. This is the x-axis, this is the y-axis. Um, and then when you have any sort of coordinates, let's say 1, 2, that means from the origin you go right 1 and you go up 2 to get this point here. And then it's basically x, y, and if you go negative, like, I don't know, -1, -2, then you go the opposite direction. And these are the coordinate system we're used to, but also there's another one, actually, polar coordinates, where it's really into circles, sort of. So then this goes by the system r theta, where r is a distance from the origin, and theta is the angle. So this would be 0 degrees, this would be 45 degrees, this would be 90 degrees, and so on. So if I had something like this is 2 away, and the angle is 45 degrees, so then this would be written as 2 45 degrees, or it might also be written in radians as 2 pi over 4. So, why do we care? Well, first of all, it's useful for algebra. So, for example, what does x equal 1 mean? Well, if we graph it, it basically means a line. It means no matter what, x is always going to be 1. But what if there's something more complicated? Like, what if you have something like y equals, I don't know, x squared plus 2 over x? Well, that looks a bit odd, doesn't it? But if we draw it as a curve, then it makes things a bit easier. So in this case, it would look something like this. And maybe that helps, maybe it doesn't, but either way, it still gives you a better way to represent algebraic equations and like relations. Now, but if the coordinate plane can do that, then why do you even care about the polar plane? Well, we'll get to that later, but actually, before I go into that, I should mention that in the polar coordinate plane, equations look a bit differently. For example, if I said something like r is equal to 3, well, if it was like x equals 3, it would look something like this, right? Just a straight line. But no, because r refers to distance. So say that this is 3, that means r equals 3 actually means a circle with radius of 3. And then if you have something like theta is equal to 30 degrees or something, well, that would actually just be a line all the way here with this as 30 degrees. And that makes things a bit different then, because instead of it being into like x and y values, you're talking about it in terms of radius and in terms of angle. And maybe this makes things a bit easier. For example, it makes drawing a circle a lot easier. But then, on the other hand, it makes things a bit complicated. Like if you want to draw a parabola, like y equals x squared, if it was just the Cartesian plane, it would just look like this. You can just draw it as y equals x squared, but then like how would you represent that in the polar coordinate plane? But still, like if you wanted to draw a circle, you can just write it as r equals 3, but then if you want in the Cartesian plane, it would be something like x squared plus y squared equals 9, and that's a bit annoying to work with sometimes. So just as a general thing, the Cartesian coordinate system is usually better for straight lines and parabolas, while the polar coordinate system is better for circles. And at the same time, the coordinate Cartesian plane is better for translations and reflection. Like for example, if you want to translate this left, it would just be, if you want to translate it, sorry, if you want to move this left, like this, then this would just be y equals x plus 2 squared, and that's easy to do. And it's also good for reflections, because if you wanted to reflect it like this, then you would just be y equals negative x squared. But then the polar coordinate system is better for rotations, because say you have some point, let's say you have some point, say the 30 degrees again, and let's say that r is equal to 2. So this would be 30 degrees. And if you wanted to rotate that another 30 degrees, it would just turn into 60 degrees. But if you want to do this in the Cartesian plane system, that would be a bit more complicated. Now let's go back to the Cartesian system. Well, the most simple equation is probably a straight line. And a line would take the form of y equals mx plus b. And if I draw the plane, be something just like this maybe. And then, okay, so what does m represent? Well, m is the slope line, or rise over run. So if we take this, the change in y, change in x, so m is equal to the change in y divided by the change in x. And since this is a straight line, this ratio will always be constant. And what does b mean then? Well, if we think about it, when x is equal to 0, then y would just be equal to b, right? So then this is known as the y-intercept, or just where the line crosses the y-axis. Of course, there's also like the x-intercept, and then we just solve that by having y equals 0. So then mx plus b equals 0, and then we can rearrange this into x is equal to negative b over m. So that would just be the y-intercept there. Also, just something to keep in mind, if it's a horizontal line like this, well, there's really no slope, because it just goes up infinitely. So if you would say that a slope, I guess you could say it's infinity, but that's not a number. So normally we just say that the slope is not a number. And just some properties of the slope. If two lines have the same slope, but they are different lines, then they are parallel. And if two lines are perpendicular to each other, which means they have 90-degree angles, then, and let's say this has slope m, this has slope n, well, that means m is equal to 1 over n, negative 1 over n, I mean. Now that's just something to keep in mind, like if they ever ask you about two perpendicular lines, now you can know how to figure out the slope of the second line if you have the slope of one of the lines. Now when you want to plot a point, well, I mean, if you want to plot an equation, a good strategy is to plug in various values for x and connect it like that. If, like, for example, something like, I don't know, y equals 2x plus 3. Now, there's two ways to do this, the easy way or the hard way, or really the long way or the short way. The long way would just be plug in a bunch of random numbers, like say one easy one is x equals 0, that would be at 3. Then maybe x equals 1, that would be 1, 5, and then so on. Or really you can just draw 2 points and just draw a straight line through it. That's another way to do it. But in general, since you know when it's in this form, 2 is equal to slope, the y-intercept is 3, so you can really just start at this point 0, 3, and then draw a line. Every time you go right 1, you have to go up 2, and that's really what the slope represents. And for the for the x-intercept, this point, you can just figure that out as negative 3 over 2 just by rearranging the equation when y equals 0. Now, next thing, distance formulas. Now, if you have 2 points, let's say this is 1, 1, and this is, I don't know, 4, 3. Now, basically just Pythagoras. So to get this, you have to go to the right by 3 units, and then you have to go up by 2 units. And then a squared plus b squared equals c squared, so then the distance here is equal to square root of 3 squared plus 2 squared equals the square root of 13. And maybe that's not a nice number, but then you have it. The distance between these 2 points is square root of 13. And you can just write this as a general rule. If you have 2 points A, B, and C, D, the distance is equal to square root of D minus B squared plus C minus A squared. And this is called the distance formula. Also, just as a side note, if you're working in like 3 planes, like you have something like A, B, C, and D, E, F, you can still apply this as the square root of F minus C squared plus E minus B squared plus D minus A squared. Except I guess you really haven't gone into the z-axis, so you don't really have to worry about this. Now the distance formula can be used to draw a circle. Like if you have the square root of x minus a squared plus y minus b squared, and this is equal to r, or as it's more commonly written, x minus a squared plus y minus b squared equals r squared. Now, this is the general form of the equation of a circle, and basically a and b represent how they've been translated. R would be the radius of the circle, and then AB would be the center of the circle. So just as a quick example, if you have something like x minus 1 squared plus y minus 1 squared equals 4, this would be a circle with an origin at 1, 1, and this would have a radius of 2. And keep in mind that it's not always going to give you to that nice. Sometimes it might be something like x squared plus 2x plus y squared plus 5x plus 7 equals 0, or something like that. And you just have to use completing the square to write this in the general form. I guess the final thing is just coordinate geometry can be used to find intersection of points. So if for some reason you have something like y equals 2x plus 3 and y equals x squared or something, and you just want to figure out first whether or not they actually intersect, and 2 where they intersect if they do. And then you can plot the lines on the coordinate plane. That's one way to do it. Draw this x squared and 2x plus 3, something like this. That's one way, or you can just also figure it out algebraically. 2x plus 3 equals x squared minus 2x plus 3, minus 3 equals 0. This is x minus 3, x plus 1 equals 0, so then you can figure out that they intersect at x equals negative 1 and at x equals 3. Or you can also do the more relatively simple way and just draw it on your graphing calculator or on Desmos. Just keep in mind, like in this example, they can intersect more than once. Like it intersects one here at x equals -1, and if this is continue up, they would also intersect once here at x equals 3. Anyways, I guess the last thing to talk about is something called analytic geometry. Now, what this basically means is if you have some sort of problem like this, and like ask you for, I don't know, the area of the triangle, but instead of giving you side length, it would just give you coordinates like, I don't know, 1 1 um 5 1 and I don't know 5 3, and it would just give you these 2 points and ask you to find the area of the triangle. Now, when you do that, I guess one thing to do is just first draw out the question, just so you know what the heck they're talking about. And afterwards, you'll have to solve it. And this will sometimes require algebraic work. Sometimes you can just draw it out and see what happens. But just something to keep in mind that geometry doesn't necessarily always just have to be shapes drawn out for you. And sometimes they might have you do the work for them. And yeah, I'll just leave you with a question like that. So there's a square. It's okay, that's a badly drawn square. Its center is at -17, 23. It has side length of 4, and its diagonals, so basically these lines, are parallel to the coordinate axis. Now the question is, find the coordinates of its vertices. Now I guess I could draw this out for you, but that would make things a bit too easy, so I'll just tell you to have fun with this.